All right, so what's up with these functions? So I want you first to recall with me that cosine squared t plus sine squared t equals 1. And you may not have seen this before, but I'm going to show you because it's kind of the perspective we need to take for our functions. So if we set x equal to cosine t and y equal to sine t, let's call this equation star, then equation star becomes what? Well, x squared plus y squared equals 1, which is the unit circle. And so what I want you to realize is the following. So if you sketch a graph of the unit circle with me, and let's just do that. Whoa, my circle has there we go. Let's make that no fill. There we go. Okay, much better. There's my unit circle. You pick a point on the unit circle. You can think about that point as being x comma y, of course, but x we said was cosine t, y is sine t. And you can think about t as the angle here. And I want you to realize, if you think about the area, let's shade this in and think about the area of this piece of pie. By the way, a highly relevant problem is the area of a piece of pie. Thanksgiving is around the corner. There's lots of pumpkin pies to be thinking about. I guess I just dated this video. I'm recording this in the fall. You can see October up there in the corner. So the area of this piece of pie, it turns out the formula is 1/2 times the radius squared times the angle t, which is just t over 2. And so the point is the angle t is always 2 times the area. Okay? So t is always 2 times the area. Okay. That's trig functions. And you might not have realized that trig functions, when you set x equal to cosine t and y equal to sine t, and you let t roll from 0 to 2 pi, you'll actually trace out the unit circle. These are called parametric equations. You'll see them a lot in Calc 2 and Calc 3. We're not going to do a lot with them now, but that's the perspective that we need. So now, the next thing I want us to do is I want us to recall that cos squared t minus sinh squared t equals 1. And I'm going to play the same game. So I'm going to go ahead and say, look, if we set x equal to cos t and y equal to sinh t, let's call this equation double star, then equation double star becomes, it becomes x squared minus y squared equals 1. And you may not know what that looks like because we don't cover these things as much as we used to back in the good old days, but that's just a hyperbola. It's a hyperbola opening along the x-axis, and it looks something like this. I'm not going to try to graph it too detailed, but it looks something like that. Same basic shape on both sides. Mine's a little bit off, but you can use your imagination. Okay, so what I want you to think about and realize is that as you let t vary, you're going to trace out this side of the hyperbola. I want to let t be positive, let's say. So if I let t, I said t be positive. I can take negative t values as well. Doesn't actually matter. When I let t vary, I trace out the hyperbola. So I'm actually going to erase this side. But as t varies, I'm somewhere here. So this is a point, and I get cos t, comma, sinh t. And as you vary t, you trace out this hyperbola, this side of the hyperbola, something like that. Okay. Well, the point is, you can still form an area. I can still imagine this little piece of area. I'm going to need to zoom way in now and make this tiny, but I still get this little bit of area in here. Oh boy, my marker tip is too big. Okay. And it turns out that this area A, let's call this area A, turns out that T, again, is always 2 times A. So there's a relationship between the area that you pick, right? You pick one here, you get this little area. You pick one way out there, and things change. Actually, let's think of it as more positive like that. There we go. My picture is not drawn quite right. It would actually go more like this, and so the T's would give you different areas. Okay, so the point is this. There are incredible similarities between trig functions and hyperbolic functions. Really, if you called trig functions circular functions, then everything would make sense. When you set x equal to cosine t, y equal to sine t, you trace out a circle. When you set x equal to cos t, y equal to sinh t, you trace out the right branch of a hyperbola. And furthermore, there's this interesting relationship between areas where t is always twice a certain area. And everything else sort of falls from that. So let me mention one last thing, and then I'll do some applications as well. So actually, let's do that in the next video. I think I said there was one more. I'm going to do one more on top of that. So next video, we will wrap this up for good. Promise.